Hello folks, welcome to the Summers High School Metal Shop. In this video today we're going to be covering the steps to make the handle for the screwdriver project on our metal lathe here at the school. The overall length of our part is 3 3/4 inches, but we don't want to cut our material to that length. We want to rough cut it a bit longer. Remember that we need material to hold in the chuck of the lathe as well as a little bit of a buffer so that we do not have to run our tool right up to the chuck jaws. To cut this aluminum, I'm going to be using the horizontal bandsaw. I've already taken the liberty of marking out my piece. I'm going to rough cut this to about 6 inches. That's going to give me plenty of material to hold in the vise, as well as that buffer that we need between the end of our workpiece and the chuck jaws. When setting up the saw, make sure that your material is clamped securely and that your fingers are clear of the cutting area. Now that we've cut our material to length, it's time to get set up on the lathe. Before using the lathe, I'm going to make sure that I have no loose clothing, my long hair is controlled, as well as no lanyards or anything hanging off of my person that can get caught up in the machine. Anytime I'm doing any lathe setup, it's important that I turn off the main power to the machine. That way I avoid an accidental startup. The first step we're going to do is we are going to face one end of our part. This is going to give us a clean edge to start work off. When facing the part, I don't need to stick it very far out from the jaws of the vise, or chuck I should say. I'm going to only stick it out about 1 inch. Notice anytime I use the chuck key, it is always attached to my hand. I'm never leaving it in the chuck unattended. Now I'm going to set the proper tool angle for facing. I'm going to bring my tool in close. When setting my tool for facing, I want to make sure that I have a good clearance or back angle on the far side of the tool. And with this particular tool profile, my lead angle or my lead cutting edge should be approximately perpendicular to the face of the part. Remember, we're going to be cutting from the outside towards the center when facing. When facing the part, I'm going to be controlling the depth of my cut with the feed hand wheel, and I'm going to be actually cutting using the cross slide feed. Before I begin cutting, I make sure that my tool is clear of my material. And begin by making a light pass across the surface. We now have a very clean machined end. If we found a little point in the center, it would tell us that our bit height was set either too high or too low, and I would need to adjust the shim stack under the tool bit. The next step in our process is going to be to center drill the face of the part. We are going to do this to accept the live center that we will need to support the end once we slide it out of the chuck. To do this, we're going to use our tailstock with our drill chuck inserted in it. I need to move my tool and carriage clear of my part, but also close enough so that I can slide my tailstock in. Be careful not to ram the tailstock into the part. Once the tailstock is in position, I'm going to use the lever on the back side of the tailstock to lock it in place. It now will not slide along the ways. I'm also checking to make sure that my tool my tool post and my compound rest are clear of the chuck. I don't want this chuck jaw coming around and striking the tool, causing a crash. When center drilling, I don't want to drill in too far. We merely want to come close to the end of the taper on the center drill bit. I start the lathe in the normal rotation direction and will slowly feed the bit into the material. We should have a taper that ends at the edge of the part. If we have any flat in there, that means we've gone too deep. We will need to reface the part to bring that down. This end will accept our live center nicely. I now need to replace the drill chuck with the live center. To do so, I'm simply going to back off the tailstock until the drill chuck releases. This is held in position by a Morse taper on a pressure fit. There is a stop at the back of the tailstock that will drive the implement out. I'm now going to make sure that my Morse taper is clean, that I have no debris in the tailstock, and I simply slide my live center in until it locks in place. I'm now going to set up my material for my diameter turning. Of note, I've turned the main power off on the lathe before working on any of this area. I'm going to loosen my chuck and slide my material out. We remember that the part that we are working on is 3 3/4 inches long. I'm going to have about 4 1/4 inches sticking out of my chuck. This will give me a little bit of room before the end of my piece, allowing me to actually turn a little bit past the end of my actual part. In addition, I've got plenty of material in the chuck jaws so that I know I'm going to have a nice secure hold. Once I've locked my material in the vise, it's now time to set my tool. I'm going to bring my tool in and set for my cutting angle. I'm going to set the left edge of the tool so that it's almost perpendicular to the stock. Again, it's very important that we have this back angle set so that it does not drag along the part as we cut. Once I set a satisfactory tool angle, I will make sure that I lock this tool in position. I like to bring my tool to about where I'm going to start turning and leave it in this position while I set my tailstock. I'm going to slide my tailstock in position so that it is just shy of the carriage. Once it's in position, I will lock the tailstock first. I will then bring my live center into position and in contact with my part. I will add a little bit of pressure with the hand wheel and then lock the quill lock on the tailstock. I'm now ready to begin diameter turning. To begin diameter turning, I am once again going to make sure that my tool is clear of the material, that my chuck cannot strike anything, and that everything is locked in position. I'm going to begin by making 2 to 3 light passes down the material. I'm going to stop about 1/4 to 1/2 inch shy of my chuck. As a new student on the lathe, we are not going to use power feed initially. You're going to make your first several passes by using the manual controls on the machine. I've engaged with my material, and now I'm going to consistently and smooth feed my tool down the material. Taking care when getting close to the chuck, I'm going to stop shy of it. Return my tool. I'm going to advance the tool approximately 20 thousandths and begin cutting again. After my second or third pass, I'm going to stop the machine. Notice I have not moved my tool. I've left it in position. We are now going to talk about how to set our digital readout to monitor the diameter that you are cutting on your part. To set the digital readout, we're going to need a dial caliper. Note that I have shut the main power off of the lathe before working inside the work envelope. I'm going to take a measurement on my part, and I'm going to measure the current diameter. This is the diameter that the tool just cut. I have not moved the tool's position. If you move the tool's position, this process will not work. The current diameter of the part is 0.984. In order to set our DRO, if the power has been killed to the lab, the DRO will be flashing. First, we press the clear button. By default, the digital readout will read to the 10,000th of an inch. We do not need to be that accurate, so I can press the plus minus button so that my digital readout is now reading to the 1,000th of an inch. Note that the x-axis lines up with the x button. This is the readout that we are going to monitor for diameter. The z-axis lines up with the z button. This is the axis that runs along the lathe. We are not going to use the z-axis for this part of the project. The diameter that my part measured was 0.984. To enter that in the digital readout, I press X 0.984 and then press enter. As I move my tool in and out, my digital readout will now reflect the diameter that that tool is cutting. It is important to note that if I change my tool or change my tool angle, I will need to make a light pass and reset the DRO. At this point, I'm now going to continue roughing my part down, meaning just trying to get material off of the part to approach my final diameter. The final diameter on the part, or the largest diameter on this part, is 0.750, or 3/4 of an inch. So what I would be doing is continuing to use the manual feed and cross slide wheel, taking off approximately 20 thousandths at a time, or 2 100ths at a time, until I got down close to my diameter. I would then begin making lighter passes until I approached the final diameter. Once you have made a few passes and feel comfortable, you can engage the power feed on this machine. In order to set the power feed, we first need to engage the feed rod. This is done at the headstock of the machine. The power feed engagement lever is located right here on the headstock, just below the center line of the spindle. Under normal spindle rotation, where our work is coming down onto the top of the tool is located in the front of the part, we want to typically feed to the left. Our tool's cut from the right to the left in this particular instance. In order to engage the feed rod and allow me to access the auto feed, I need to pull the pin and simply drop the lever down. It will lock into position. Occasionally the gears will not mesh in which case you will need to slightly rotate the spindle by hand until the gears enable you to mesh. Now, when I start my spindle, I will be driving power to the feed rod and subsequently to the carriage. To engage the power feed on the carriage, the lever is located just below the cross slide hand wheel. If we want to power feed along the part, as we are going to be doing in this instance, we will pull the lever out to the side and lift it. This will engage the power feed while the spindle is running. Pushing it down stops the power feed and returns it to neutral. If I wanted to use the power feed for a facing operation, I could push this lever in and then push it down. This will engage power feed to the cross slide. It is very important, once the feed rod is engaged, that you always double check your power feed before starting your spindle, as you do not want any unwanted tool movement on startup. I'm now going to make a few passes using the power feed. I always stop shy of the end and finish manually. Return the tool. Set your cut depth and go again. This process will continue until we reach our final diameter of 0.750. Done. The next step is going to be to mark the various features of our part. I'm going to use the tool I've currently got in the tool holder with the Z-axis to mark out the beginning and end locations of the grooves and the knurling pattern. To do this, I'm going to set the nose of my tool to Z0. And I'm going to take my measurements off the face of the part. As you can see here, I've lined up the nose of my tool with the very beginning of my part. What I will now do is go to my DRO, press the Z-axis button, and enter 0. What you will notice is that I move down the part, my values are going to go negative. So as I travel down, we see my values negative. Now my first feature begins at 0.25 inches in from the end. So I move my tool into the position, now granted it's negative, of 0.250. What I will now do is start the machine and just put a little line using the nose of the tool. I will repeat this process for the beginning of each feature. Now that all my features have been marked and my part is turned to its finished diameter, I'm going to begin adding the features. As long as my regular tool is still in the tool post, I'm going to add the chamfer to the end of the part. We're going to do this manually, and I'm going to do it by using the edge of the tool, and I'm simply going to angle my tool to 45 degrees. It is important to note that I am setting this completely by eye. The chamfer on this particular part is non-functional and decorative. You could go as light or as heavy as you wish. That's why it is acceptable to set the angle by eye. If this were a precision part and this chamfer was essential to its function, we would most certainly be doing this more accurately. We would be using our compound rest, setting that to 45 degrees, and actually physically cutting the chamfer by moving the tool across it at an angle. I'm now just going to come in and take this edge off of the part. After cutting the chamfer, we are then going to need to remove this material here to create the notch. To do so, we are going to need to use a different tool. This tool has a round nose profile on it that will give us the radius of that groove. When changing tools, I'm going to make sure that I have the main power of the lathe turned off. It works out quite nicely. This particular tool is actually perfectly centered when it is put into this tool post without any shims. I have measured this in the past, but if you are unsure, you could certainly slide your tailstock out of the way and measure the cutting edge of the bit to the nose of the live center. This bit should be set perpendicular to our part. To do that, we are going to be using a machinist square, and we are going to set it to the edge of this cutting bit. I put one end on my part, the other end, or the other edge, along my tool, and I will adjust the angle until the tool is perpendicular. This tool can cut both directions. So what I'm going to do is I'm going to start taking away material here, moving back and forth, creating the groove feature. After a few passes, I'm going to stop with my tool in one position and repeat the process I did for setting my DRO to the tool. I turn off the main power, measure with my dial caliper. I have a value of 0.711. In my DRO, I enter X 0.711. The final diameter of this feature is 0.5 inches, so I will continue making passes back and forth until I achieve my final diameter. The next part of our process will be to set up for knurling. This will create the diamond impression and the handle of the screwdriver in order to add grip. It's important when we are setting up our knurling bit that we set it, it does move, but we set it so that the center line of the tool is even with the center of the part. So we will be adding shims underneath this as we place it in our tool post in order to ensure that that happens. I've now centered my bit. Next, I need to square my knurling tool to the part. I'm going to use a similar process to what I did in the previous step with the other tool. I'm going to square up the body of the knurling bit, the part that actually moves up and down, to the part, and set my tool post. I'm going to line my knurling bit up in position for the beginning of the knurl. We are going to knurl from the chuck side towards the tailstock. I've found with this particular setup on this lathe, that is how we get the best results. Before we can begin the knurling process, we need to set our lathe into the back gears. To do this, I make sure that my main power has been switched off. I'm going to open up the lid. I'm going to rotate my spindle until I find the pin at the top of the gear. From here, I will pull the pin out and twist it 90 degrees so that it sits disengaged. This frees the spindle from the pulley drive. I now open the back door of the machine, or side door I should say, and I drop the back gears in by pulling the pin. You may need to rotate the gears slightly to get them to mesh, and the pin will lock in place. I've now engaged the back gears and dropped from 850 RPM to 200. The last step before I can begin knurling is I want to reverse my feed direction. I want my tool bit to travel that direction. So I pull my feed direction pin all the way up to the top. Now when I engage my power feed, my tool bit will move away from the chuck. The knurling process produces quite a bit of friction, so it's important that I use a lubricant. I'm going to start by adding a little bit of oil to the area that will be knurled. I have my tool very lightly engaged in the part. What I'm going to do is I'm going to engage the spindle and start it and begin using my cross slide to add pressure until I see the diamond pattern start to form. Once I see the diamond pattern form, I will maintain that pressure with the cross slide and I will engage my power feed. Now engaged my power feed, and my knurling bit is moving down the part. Occasionally I will need to add oil during this process. As I approach the end of the knurling feature, I stop my power feed and disengage my spindle. We now have a nice diamond pattern embedded onto the surface of the part. Next, we're going to add the groove feature just past the knurl. This is done using a cutoff grooving tool. It has a square-edged 1/8 inch wide bit that we are going to plunge straight into the part. Like the other indexed bit that had the round nose, this particular tool does not need shims underneath it. It does need to be squared to the part. So I will square up my tool using my machinist square. Next, I will set the location in my DRO. And to do this, I'm going to just come up until my tool touches my part, and I will enter X.750 as that is the diameter of the part in that location. I will locate where my cut will begin, back my tool away from my material, and prepare to cut. This operation requires the lathe to be in the back gears, just as the knurling does. I am going to engage the tool and continue to cut straight in using my cross feed until I reach a depth of 0.50. Oil is also necessary for this particular part of the process. I am using steady feed pressure, watching the chip curl away. Occasionally, I will need to add a drop or two of oil to the process. As I'm cutting, I'm monitoring both my part and watching the digital readout. I am going to continue plunging until I reach a depth of 0.500. I've reached final depth, the tool moves straight out of the part. After cutting my groove, I'm now going to take the machine out of the back gears. I will turn the main power off, lift my cover, and open my side door. Taken out of the back gears is the opposite of putting them in. I first pull the pin and release the gears. Next, I rotate my spindle to bring the pin up to the top. Pull the pin out and twist 90 degrees until it drops into its location. The final step is to rotate the spindle until I hear the pin engage with the pulley system. I'm now back in direct drive. Next, I'm going to be tap drilling, meaning I will be drilling a hole so that I can thread the end of my part. I've set my drill chuck up with a number 7 drill bit, and I am going to be drilling to approximately 1¼ inches deep. As I drill, you will notice that I go in and then come back out to clear the chips. We don't want to let the chips build up inside of our hole because it can actually cause the drill bit to break off inside of the part, which would most likely ruin the part. I'm now ready to begin cutting the threads. To do so, I'm going to need a 1/4 20 tap. Taps are used to cut internal threads in holes. This particular thread will have a 1/4 inch diameter and 20 teeth per inch. I find when threading set up on the lathe that it is very useful to start my tap with my tailstock. This will help prevent me from beginning my threads at an angle. I am also going to need to lubricate the hole and lubricate the tap. Failure to do so can result in breaking a tap, which is a very hard cutting edge that will end up stuck in the hole, ruining the part. Also, I have turned the main power off of the lathe as I do this. In order to begin tapping, I'm going to place the nose of the tap at the edge of the hole, and I am going to add light pressure with the live center. There is a spot drilled in the back of the tap handle. I then begin cutting my threads by twisting the tap and adding light pressure with the tailstock. I am not forcing it, I am simply using it as a guide. Once I get a couple turns, I can pull the tailstock away. As a safety precaution, remove the live center. Since we are going to be working in the machine envelope, we don't want to stab ourselves in the back of the arm with this. I will now begin cutting my threads. I will rotate the tap about a turn to a turn and a half at a time, and then back it off a half turn. This will break the chip, and it is a matter of simply threading in a little, breaking off the chip. Every little bit, I need to remove the tap by threading it back out of the hole, and I need to clean the chips out of the flutes. Failure to do so can result in the tap binding inside the hole, and you will then end up breaking it off. After all this work, it would be a shame to ruin the part in the last few steps. Use a light touch. You are better off breaking the chip more frequently and cleaning the flutes more frequently. I will continue to thread until I feel the tap reach the bottom of my hole. Once we have finished hand threading the part, we now need to do what's called parting, which is going to be actually separating the part from the remaining stuff. To do this, we're going to use a parting tool or a cutoff tool, and we're also going to need to put our lathe into the back gears. My main power is off, and as before, I rotate the spindle until the pin is at the top, pull, and twist. Opening the side door, I can take and engage the back gears. For parting, we're going to use the same square edge tool that we used to create the back groove. This tool must be square to our material. I'll use, once again, my machinist square and square the tool bit to my material. It must be secured in position. I will now use my machinist square to set 0. I am going to set 0 to the face of the part using the right side of my cutoff tool. And I will move it until the two are flush. I'm now going to use my digital readout and set Z to 0. This references the right side of the cutter, which is what will determine the length of my part. At this point, I can now move my cutter into its correct location, which for this part is at negative 3.75. Once I've located my tool, I can now begin the cutting procedure. I'm going to need to use oil, and we will do nearly the exact same thing we did with this groove. However, now we are going to go all the way through the part until it drops off. It is very important to never use a center or tailstock when parting, because it can actually cause the part to pinch on the cutting bit as it cuts through. I'm going to add a little bit of oil, start my machine, and progress straight through the material at a steady cross slide feed. We only have a couple steps left. I need to now face the opposite side of this part in order to remove the debris from parting, as well as give myself a clean, finished end. The final step will be to add the chamfer to the back side. We will do that the same way we added the chamfer to the front. I'm going to flip my material in my chuck and clamp. I do not need to have a lot of material exposed. 3/4 of an inch to an inch will do. Using our original cutting tool, I will set it for a correct angle for facing. And I will put my lathe back into direct drive. My lathe is back in direct drive, normal speed. I'm going to go ahead and face this part. I'm going to start by removing this little nub, and then I will continue on to do a very, very light facing pass. My final process will be to put the chamfer on this part. I'll rotate my tool to 45 degrees. And I'm just going to come in and add a taper to that edge. Turn off my main power, release my part, and it is now finished.